My name is Paolo, Iodice, for those who came today. I'm a field account manager for MTS in Italy. And with the help of many, I helped to organize this seminar. So this presentation talks about component testing. During those days, yesterday mainly, we saw a lot of presentation of our customer that they were showing you how they test in their laboratory and how they do it. And today I will show you which tools they use to do those tests. So this is just an example, and as you can see, there is one actuator, one specimen, and but there are many more components to perform this test. So as Steve said before, we need to have an hydraulic pump to pump the flow, the oil. Then we need to have an hydraulic distribution. Then we need to have some piping. We have the actuators, as you can see. And of course, we need to have something to measure, so a load cell and a displacement transducer. And we need to have the reaction brackets and the basement, as Wolfgang just explained, how those are designed. And in addition to all of that, of course, you need a mean to control the test, so a controller. So I just show you, in this picture, I'm trying to represent the MTS portfolio of products that we have to do those tests. So we have a various number of equipment that can be used to perform tests in your laboratory. And we call those systems a fast lane or test line. So basically those are all modular components which can be used to carry out any kind of test. So you can combine those components in different way to perform different tests. So through those components, you will be able to perform very flexible tests and in a very adjustable fashion. So as you can see here on the top, we're just showing a load frame. So this is what was used yesterday by the gentleman of the University of Pisa who showed us the 3D printing testing. And you can see we have controllers and software. We will talk about controller and software more later. We have hydraulic pumps, because we need to provide the power to the system. We have hydraulic distribution, and we have actuators. So we have many different styles of actuators. I will show you very briefly the style of actuators that we have. Okay, so this is just a representation. So this is another picture, shows you also our software. We also have, with the help of Wolfgang, into our product line, we have portal frame, reaction brackets, and we have many pre-configured systems like elastomer systems, damper system, and material test systems. So we didn't talk about material test systems, but we have a lot of systems to characterize and understand the property of the materials. So from the simple tensile testing to the very dynamic testing. Okay, so which are the actuators that we have? We have a wide range of actuators available. So, and why do we have different actuators? Is because we want to have special actuator for each different application. So we have small actuators, the series called 242, which are low force but very high dynamics. So if you have a very high dynamic event with low force, you will need to use one of those actuators. Then we have the so-called 244 actuator, which are very broadly used. All the presentation you saw yesterday, they use those kind of actuators. And we have the 247 actuator, which have very long strokes. So there are special applications where you need to have very long strokes. So we have those actuators as well, low strokes and low frequencies. And we have the 248 actuators, which are used for vibration application, like for Porster testing. It's difficult to... Okay, so we also have the torsional actuator. So for those of you who has to test drivetrain components, so you have to apply a torque. We have several of torsional actuator. We have some customers here who use those every day in their laboratory. And we have a wide range of product from 200 Newton meter to up to 82 kilonewton meter, so very big actuator, very high, also dynamic if needed. So we have application where those actuators can run at frequency up to 500 Hertz. So this is shows how those torsional actuator can be used. So you can see a typical configuration. We have the torsional actuator, the torque cell on the other side, and the base plate, the reaction bracket. Okay, so as Steve explained, we need to have, in order to perform those tests, we need to have an hydraulic power supply. And so you can see in this picture how the system is normally organized. So we have the hydraulic power supply, we have the hard line, which needs to go into trenches, we have the hydraulic service manifold, and we have accumulation. And Steve discussed about accumulation. So for those who were here yesterday, you saw our pumps. There are some pumps here at Streparava. We can show you those pumps today again. And we have developed very quiet pumps. The reason why, because in the laboratory you want to have a very quiet environment. So we're using submerged pumps. The pumps are running into the oil, so it's very, very quiet. And so we have a very low noise. And all the pump that we use, they have variable flow, so the pump consumes as much power as you need, and we have many features even to reduce further the oil consumption and the power consumption. And so those pumps can be connected together. Probably I think it will be best to go afterwards to the laboratory and see the pump again running. So you will see that they have almost, here in Streparava, they have alpha megawatt of power installed, and the noise the pump makes is very, very low. Okay, then after the pump, we need to have something to open and close the oil flow to the actuator when I want to run my test. And we do this through this component which we call HSM, which normally serves three purposes. One is to open and close the oil flow. The second is to have some filtration, and the third has some accumulation. And as we said, the sizing of the accumulation is very important. So every time that we provide you a system, we have to size the system accordingly to your need, and we're going and we do all those calculations in order to make sure that there is enough accumulation into the system which will allow you to perform the test you need. And we have different tools to do this, and this is just a representation of the tool we normally use. So basically, normally we go through the definition of the frequency you want to run the test. We want to understand the displacement and the velocity and the acceleration you want to achieve during your test. And through, with the use of our tools, we can size those. We can size the system accordingly. Okay, so we didn't discuss much about flex test, about controllers. We do have controllers, of course. We need to perform the test. In order to perform the test, we need to control the test. And to control the test, we have a long histories of developing controllers, and we have our latest controller is called Flex Test. We have a family of products. I will show you later. So what is the purpose of the Flex Test? The Flex Test has to command the pump, so has to start and stop the pump, has to command the manifold, has to close the loop. Of course, all the tests we run are in closed loop mode, so has to manage the closing of the loop, has to measure, so you can use it to measure gauges through various gauges that you can have on the bench. And it also manages the safety, because nowadays it's very important to have a safe environment. And we can also use it to communicate with external device through the buses that nowadays are more and more used on the vehicle. So like CAN bus, EtherCAT. And we also use the Flex Test to communicate with the PLC, because nowadays many systems have a PLC just dedicated for the safety of the complete system. And those are special PLC, are called safety PLC. Okay. So this is the controller family that we have. So we have a wide range of controller available depending on your application, on your needs, and how much you want to plan ahead. So if you think that in the future your laboratory will grow, we definitely can choose a bigger box where we can install much more hardware. So the beauty of our system, and I hope you capture this, is that we have designed very modular system. So everything we do is designed for the modularity. So you can increase the number of channels, you can make the system growing with your needs. So if your needs are changing, you can change the system accordingly and make it increasing. So we have a wide range of products, and you can see we can control up to 40 channels. There are certain rigs where we have to control up to 40 actuators at the same time. So, and we do this through our controllers. So this is just showing you how the controller is done. So as I said, we have a high modularity. So, and all the cards that we have into the controller are very modular, can be bought individually to serve a specific purpose. So we can condition signal, we can drive the valves, we can command all the devices into the laboratory, and we can have also communication with external device. As I said before, I mean, nowadays it's very common to communicate with external devices through buses. So our controller is suitable to communicate through CAN bus, through Ethercat, and also through ScramNet. So you can communicate directly to your data acquisition system or to your DSpace or equivalent box. So what do we, of course, we talked about hardware up to now, but we do also have a software, and we need to have the software to run the system. So, and it's very difficult to talk and present the software. I just give you some highlights. Probably if you like, we can show you a little bit of the software afterwards in the laboratory. But we have basically three software which are provided with the system. One is called Station Builder, so you can define how the test is designed, so you can design the station. So basically, through our software, you can see all the resources available, and then you can choose which resources you need for that specific test. And you do this without any hardware modification. It's just a software modification. And then we have the Station Manager, so which allows you to control your station. So you need to set up your monitoring. You can set up all your screens in the way you like it. And then we have the application tools. So we have an application tool called MPT or Test Suite or RPC. Florian will be talking about RPC later, more in detail. So, but those tools will allow you to program your test. And those are designed in a very logical way. So you can program your test in a very simple way. You just have to think about your tests you do, and you need to add the blocks to make the test running. In addition to those, I think maybe you are also interested to some additional features that we can provide with the software. We have special tools which allows you to do special tests and to do those very quickly. So we have a tool called Calculation, which allows you to make calculation among actuators, or you can define a calculation, and then you can set up in the system, and the system will use your calculation as a feedback signal. As an example, you can use a linear actuator to generate a torque. So if you know the arm, you know the force, you will be able to determine the torque. So basically, you can transform your linear actuator into a torsional system. So we have other feature as well to simplify, which is PC per station, which allows you to share the software through a network of PC. We have a software called Profile Editor, which allows you to define a profile before running the test. We have cascade control, so you can have several loops. We have time history playout, so we have the ability to run time histories. Florian will talk about time history later. And we have trend monitoring, so we have the ability to monitor how the test is performing. And we also have fatigue monitoring, so you will be able to see how the fatigue is moving during the test. And then there are additional tools, but I don't want to talk a lot about those. So the advantage of the controller is it is very flexible, very easy to reconfigure, and it can serve many, many different applications. So in addition to that, we also have a feature which is called Echo. So we are able to transmit the data of your test outside of the laboratory. We have two ways to do this. We can do either through the web, through the cloud, so we can put all the data into the cloud, so you will be able to see from your phone how the test is performing in the laboratory. So, or alternatively, we can do through a hub, so you can see how the test is performing inside your building, okay? And we have two type of, this technology is used on two applications. One is just to monitor your test, how is the test is progressing, and the other application is to monitor the health of your test and of your system. So we have special features that we can add to the machine to measure if everything is healthy. So we can measure the quality of the oil, we can measure the temperature of the oil, we can do several measurements to do some predictive maintenance. So I'm just showing you some pictures. So this is a very simple picture. So we have here 4 actuators which are contributing to perform a test on an axle. And this is a 2 degrees of freedom test that we perform on this axle. You can see the reaction bracket, the actuator, the pump, all the components we discussed about. And here I'm showing some drivetrain. It's just another example. We see the torsional actuator, the servo valve, and you can see 2 types of tests on CV joints, for example. So what we can do in addition to that, and what I think the industry is moving forward, is all the system needs to be integrated. So what does it mean? We saw the presentation from Silvia yesterday. She was talking about correlation. So we need nowadays more and more the ability to correlate and to see if our modeling correlate with what we do in the laboratory. So we do have this capability, and we do have more very advanced capabilities, so we are able to integrate into our vehicle model some components which are very difficult to model. So we can have the physical test running together with your model, and your model run with some physical parts. So for example, if you have a damper, which is very difficult to model, we can have the damper running into your vehicle model. So, and those two, they will be synchronized, and you can saw very quickly and very easily, you can change your setting of your damper in order to achieve the required performances. In addition to that, we have two techniques that we can apply into the field. Is we have the virtual and the physical working together. So we have 2 ways to do it. The way that I described before. So we use the physical system to deliver more value, to more information to the virtual system, or we can do the vice versa. So those 2 systems have been used in the field very successfully. So we can use the virtual system to deliver data to the physical system as well. So we can do the we have both techniques. This technique is called HRC. HSRC is the most advanced technique we have, and I don't think we have used on an halfway application so far, but if somebody is interested to talk about those, we can definitely do that. So last but not least, as we always say, is safety. We do have, nowadays safety is very important and is becoming more and more important. And prior to deliver any system, we have to talk very extensively about the safety, how to make the system safe. And the ISO 13849 is giving us the guidance on which type of analysis we need to do, and we do have all the features necessary to meet your safety requirement. So typically, all the servo-hydraulical systems, they must achieve at least a safety level called performance level C, but in some cases we need a D or a E. So it really depends on the application, and there is a discussion to be made. Okay, I finished, and if you have any questions, I will be very happy to respond to your questions. If you don't have questions, we are ready for the coffee. Okay, so basically just this is a very quick introduction. Each of those items, there are specific presentation, and there are a lot more information that could have been shared. So if you are interested, just ask me, and I will be very happy to explain you all the details of this presentation. Okay? So thank you very much.